Hello again, it's Cliff here from Down Under. Carrying on with the series R8 TTS versus BT30. In this video, it's sort of morphing into how you can get the best out of your TTS system that you may already have or are thinking of buying. Cheers. So while my Slant Pro is busy making parts, I've got a bit of spare time. I've got a bit of spare time to do some tests on the TTS system. So in my last video I talked about having a solid insert in the tubular 3/4 inch shank of the TTS, and this one here I've put in a close fitting piece of high tensile steel, and this is a Tormark original hollow shank, and I'll do some tests now to show you the advantages of that. Okay, hopefully you can hear me over the Slant Pro. So we're going to put in the original TTS holder and we're going to tighten it up. So at that point there, it's just firmed up on the thread, and I'm going to go to about 1/4 of a turn from there. Firmed up on the thread and about 1/4 of a turn. Now let's put in the solid one, the same Tormark TTS holder. Tightened up there, it's just firm there. And see that? I'm only giving it less than 1/8 of a turn and the same amount of tension. So if I tightened it up a bit more, I'd be getting a lot more grip on that 3/4 inch shank. Okay, I'm in the other room now where the lathe noise is not so bad. So going over this again, this is the original TTS with the 13mm hole in it. This is the one with the solid steel insert. I've marked it solid, and it is going to be more solid. If you think about what's happening when the collet closes down, it doesn't just, it's doubly bad actually, because it's tubular, but it's open at one end and it's supported by the flange at the other end. So what happens is that the collet crushes this open end more easily than this end. So what happens is you're getting less grip down this end of the shank compared with this end. So not only are you getting less grip than with a solid shank, but you're getting the grip over a shorter distance. You're not getting the full length even grip, you're getting an uneven grip. It's kind of crushing it into a tapered form with less grip on this open end. So just going over the process, because the hole in the shank is just rough drilled and it's probably not going to be particularly round or parallel, I set it up in the lathe and just took a few thou out with a tungsten carbide boring bar. It's quite hard, the steel. It's been heat treated. It's probably about 50 Rockwell C. So I put a bit of cutting oil on it and just took a very light cut with a sharp carbide boring bar to get it round and parallel again, so that I could push an insert in without getting any distortion. And then I just turned up a piece of high tensile steel, sort of a size for size fit, just a nice firm fit, and then push that in, for example in a machine vise, so that you're getting full length engagement and turning that hollow shank into a solid shank. While I'm on the subject of TTS holders, there's a big difference between the cheap online holders and the genuine Tormark holders. I know this sounds like a Tormark advertisement, but I want to explain that it's actually not that. It's actually a genuine results of a test. If you have a look online, you'll see there's some YouTube videos checking the concentricity of these different holders, and they have a dowel in here where the cutter is, and they put a dial indicator on it and turn the assembly, and then draw a conclusion as to whether the holder is any good or not. And that's a really bad way to measure something, because what you're actually doing is measuring 5 or 10 different things. You're measuring the R8 collet, the spindle concentricity, the end of the nose, how true it runs. You're also checking the TTS holder, the ER collet, the ER collet nut, and all of those different things all have errors, and they will all add up or subtract and cancel each other out and give you all kinds of variable results. So it's highly subjective, not at all scientific way of checking the quality of your TTS holder. If you want to check something, you need to break it down to its absolute minimum state and just check the individual components and their individual geometries. What's critical with a TTS holder is the concentricity of the 3/4 shank relative to the ER collet taper. For example, the ER20 collet taper. It has to be axially in line and radially in line. They're the key things, just those two things. And so you need to separate that out from all of the other errors. So if we put it in a V block, can you see that there? I'll just zoom in on it a bit better. If we put it in a V block, that's now registering the outside diameter of the shank. We bring a dial indicator into contact with the taper there, and we hold that firmly down onto the taper and on the end of the V block with a bit of pressure, and we rotate it. It's a bit hard to do with the camera there, but you can see the needle is hardly wavering other than when I waffle. But if I can hold it still and turn it, it's showing that it's very concentric. So what I found was, a bit difficult to demonstrate, but that's the principle. I'm rotating on the shank and I'm measuring the taper with a dial indicator, but you need to be pretty careful and get in close and do it correctly and rotate it without rattling it round, obviously. But if you can hold it steady, you can measure the concentricity of the taper to the 3/4 inch shank. And what I found was, on the Tormac holders that I bought over the years, they were very concentric. They were within half a thou of run out. And I bought one set of, it was 10 in a set on eBay, and it was very cheap. It was about $100 for 10, so that worked out at about $10 each. And I set them up like that and checked them, and that very first critical machine diameter between the shank and the ER20 taper was nowhere near as accurate. So if you've got errors there at the very beginning of the holder, imagine what it's like when you add all the other things. You might be lucky and they may cancel each other out, but they could also become more. In addition to that, the thread needs to be true, concentric, otherwise the nut's going to be pulling the collet off center, and the angle needs to be correct for the ER collet. It needs to be concentric in both directions. That's just measuring one part of the geometry, this particular test, but the Tormac holders are obviously made in a factory that's working to tight tolerances, because I've bought several over the years and each one was very close to spec. So this is just a reality of a test. I'm not advertising here. I'm just trying to be really honest about it. I felt a little bit bad about buying these cheap eBay parts, but then again I thought I could justify it if I tested them out thoroughly and posted online the results. And I did a PDF explaining the results a few years ago when I did this test. They were so bad that I needed to set them up and set up a precision internal grinder and grind the internal taper out to get it concentric. If your holder is not running true and your cutter's not running true, you can't do accurate work. The spiral form of the cutter, with it wobbling around on an angle or out of concentric, will generate angles and give you all sorts of funny sizes. I just found the original document that I posted online to the CNC Zone when I got these cheap holders and did some tests. So the first part is going over what I just discussed down in the workshop. In testing the concentricity and so on. Now this is interesting. On closely studying these holders, the reason for the error becomes fairly clear. The ER bore and thread have been CNC turned, not ground, and a small center machined at the ER mouth. This means the production process was probably: the holder was rough machined, heat treated and tempered back to a carbide or ceramic machinable hardness of probably about 45 to 50 degrees RC. The holder was then chucked or colleted on the shank, and the ER bore and thread machined. The holder was then held between centers and the shank and flange face cylindrically ground. The issue was probably at the chucking or colleting on the heat treated shank. That would mean the shank end center would not run exactly true, and thus the final external grinding process would be flawed. The higher priced Tormach holders ER bores are clearly internally ground. What's that old adage? I guess you get what you pay for. But it's interesting though that the production was done in this low-cost factory overseas on probably quite good equipment, but they had a fundamental lack of understanding of the machining process, because the machining process, that is quite easy to reverse engineer when you study the machine marks. The machining process was illogical. It could not obtain accurate end results. And I don't know if they're still using that process, but it's a good example of a machinist choosing a machining process who doesn't really understand the principles of generating accuracy. The document goes on how I corrected the faulty holders. I bored a concentric 3/4 inch bore that I could just ring the diameters of the faulty holders into. I set up a tool post grinder on the angle with a internal grinding wheel and ground the tapers true again. And they were obviously running quite a lot out. Took quite a bit to get them running true. So the threads probably remain out on those holders, and when you tighten up the nuts, it's probably tending to bias the collets over a little, but not such a big problem. So there's an example of the corrected holders. So, of course, I'm not saying that the genuine Tormach parts will always be of a higher standard. It's just that I bought several over the years and they were all very concentric, and I bought one set of cheap copies and it was really bad. It may be that there's others out there that contradict those findings, but if you are going to check them, make sure you check it at first principles, get to the actual original geometry, and don't check the sum total of all of the errors, or you really won't be able to conclude anything. I know in theory you could buy cheap holders and then correct the errors, but you imagine that you get that sort of error just in the concentricity between the shank and the ER taper. What if there's errors in the thread and the nut's being pulled off to one side? What if there's errors in the nut? What if there's errors in the nut taper? What if there's errors in the eccentric groove that pulls the ER collet out? You know, there's literally dozens of machined surfaces in these holders that all have to be within spec, and if they can't even get a basic thing like the concentricity of the shank and the internal taper correct, what's the chances of getting everything else correct? I just would be too scared to do that again, and I don't want to spend my time correcting errors. It's quicker to pay a bit more for a product that's probably made to better tolerances in the first place. It's just a general subject, this. There are very cheap parts available on eBay, and I've been tempted and bought them over the years, and more often than not I've been disappointed after close inspection. You know, it baffles me why low-cost manufacturers make a part that superficially looks as good, but they don't quite get it right. They just miss the boat in the key areas, and if you don't make an effort and check it, you probably will be oblivious to the problem, but it could be cursing the quality of your work without you knowing it. We're just having an earthquake. Welcome to the Shaky Isles. Oh dear. Still going, the ground's swaying. I wonder what that turn part's going to be like coming off the Slant Pro. stopped again now. Oh, adrenaline. I hate that. Oh well, I'll carry on. I was just talking about these cheap parts. I promised that I'm never going to buy them again. And then I think of an application. Oh, it'd be nice to have an ER20 to Morse taper for the lathe tail stock for a center. I'll probably only use it occasionally. I can't justify a high quality, high price. So I saw this online. It was like $10 US, including postage. You can't make it for that. The Chinese government must be subsidizing the postage. It's really, really amazing. Anyway, the cheap side of me went ahead and ordered it, and I got it here and checked it out. And sure enough, oh, I better not swear online, it was junk. I mean, the Morse taper angle wasn't even right. You know, it really annoys me that I keep slipping from time to time and supporting what is essentially dishonest engineering.
Welcome back. Aftershocks are continuing to hit the lower North Island tonight after a powerful earthquake rocked much of the country this afternoon. The 6.2 quake struck near Paumaranui. It was felt from Auckland right down to Dunedin.
A couple more details on this. Now, I know some of you are thinking, well, okay, if you're going to plug up the shank of your holder, is that going to give you enough depth for the cutter? You know, it's no good if the cutter is only going in a little way. It's got to go in all the way to the flutes. And it doesn't seem to be a problem. I've just checked that. I get a depth of about 41, 42 millimeters, and that seems to cover the standard length of the shank on most cutters as far as the flute, even with a threaded shank cutter. So that brings up the question, well, why did Tormac put holes in the end of the holders? Well, I guess it makes it more versatile. It means that you could put in a double-ended cutter or some special cutter that has an extra long shank on it. So that was probably the original reason. But I'm not saying that all of your holders should be plugged. I'm just saying have one or two, keep them aside, keep them marked when you're doing large diameter cutter work, especially if it has a long projection length. Then use them for that, and you'll get a much better grip and much less chance of TTS pullout. While I'm on that subject, I've noticed on some of the later versions with the tool changer groove of the flatted shank and the ER type holders that they have reduced the diameter a small amount. They've gone down from 13 mil to 10 millimeter holes, and I just checked that in the mill with the original test, and it is better. It's not as good as the solid shank, but it's better than the 13 millimeter hole. And so it's not quite the same soggy banana effect when I tighten it up, somewhere in between the two. So they've definitely made improvements there. So message to Tormac, would you consider getting the factory to manufacture a product with a solid shank that you could sell within your range as a special high stiffness TTS holder for ER and flatted shank that can be used for large diameter cutters? That would be a really good product to have in your range. In the meantime, if you are going to plug some of your holders to have one or two solid shank holders, it would be a good idea to plug it not just down as far as the actual shank, but to plug it right down this distance, right down into the flange area. You're still going to get enough length for the cutter holder. Just don't come down any further than that. Come down to this length, and that way you're stiffening up the whole T-shape of the flange, so this whole area becomes less flexible because you've got a close fit right down to that surface. While on the subject of cheap copies, here's an example of one here. I better not divulge the brand. I'm already bashing them hard enough as it is, but you know, there's an added problem with these cheap copies. Apart from them not being accurate, there's a bigger hole through the shank, it's over 13.4, and the undercut for the cylindrical grinding is ridiculously deep. I mean, that's really weakening it at the very worst place, down to 17.88. So that leaves a wall section there, and you've got a little skinny tube right where you need it to be strong of about 2.2 millimeters wide. I mean, that's just going to be so flexible. You're going to be holding your cutters with a soggy banana with this setup. So in summary of this video series, R8 TTS versus BT30, there's a lot to it, and there's a lot of different end use situations. Some of you will be definitely better off with the BT30 and the spindle orientation, and will be prepared to pay the higher price for that technology. But if you're on the borderline and you're considering whether you should move up or not, make sure you're getting the best out of your TTS. It may be that you're only capitalizing on half of its potential. If you can apply those 4 different improvements that we talked about in this video and the last video, it may be that TTS is adequate for your needs. Right guys, thanks for watching. Cheers.